I'm back, and now we want to talk about the gas giants Jupiter and Saturn. So they're called the gas giants because they contain a lot of gas, hydrogen and helium. In general, the size of these two planets are about 10 times the diameter of the Earth. So Jupiter is actually a little bit larger than what Saturn is, but they're roughly about the same size. And then the orbital period, so as calculated by using Kepler's laws, the orbital period of Jupiter, for example, takes 11 years to go around, and for Saturn, it takes 30 years for it to go around the Sun. And then the rotational period of each of these planets is roughly 20 times the rotational speed of the Earth. So the Earth goes around, for example, it spins once every 24 hours, but these two planets spin roughly 20 times faster than what the Earth does. Let's take a look at the surface clouds of Jupiter, and we're going to concentrate mainly on Jupiter, but Saturn is going to be very, very similar. So first thing that you notice about Jupiter is it's got all of these different bands, and the different bands have different colors. So the different colors of the clouds of Jupiter are as a result of different kinds of gases that are in the atmosphere. So you'll notice in the table there to the side that it does have these grayish kinds of clouds, and those clouds are made of just plain old water, the same kind of water that we have here on Earth. Then you'll also notice, though, it has some orange and it has some yellow clouds as well, and some of those clouds are made of ammonia, for example. So why do you suppose that those different clouds form at different heights? Okay, think about from the previous lesson, how did a cloud form? So you started off with moist, warm air, and then it started to rise into the sky. And then as its temperature dropped, it eventually got to the point at which that particular substance changed from a gas to a liquid. So similarly on Jupiter, these different chemicals, water and methane and ammonium cyanide, I believe, those are going to condense at different temperatures, which means that they're going to condense at different heights in the atmosphere. Okay, now let's take a look at the inside of the gas giants, Jupiter and Saturn. So you'll notice that at the surface of Jupiter, it has hydrogen and helium, and the hydrogen is in a gaseous state. Okay, now the deeper you go into a planet, the greater the pressure gets, because pressure is going to be caused by the weight of all of this material that is on top of you. So that the deeper you go into any kind of a planet, the greater the pressure is going to get, and also the greater the temperature is going to get. So eventually, at a certain depth inside of Jupiter, the pressure is so great that the gaseous hydrogen changes into liquid hydrogen. And then as you go even deeper into Jupiter, that liquid hydrogen changes into metallic hydrogen. Now don't get the idea that whenever this liquid hydrogen changes into metallic hydrogen, that it's going to look like a metal and is going to be hard and is going to be silvery. So what do we mean by a metallic hydrogen? Means that the pressure is so great that the electrons come off of the hydrogen atoms and then are able to basically flow through the ionized hydrogen. Okay, so hydrogen consists of one proton, and then it's got one electron in orbit around it. So if we increase the pressure enough, those electrons will come off. then we have ionized the metallic, the hydrogen, and then those electrons are free to go anywhere that they want. Well, that's the definition of a metal. In a metal, the electrons are free to go anywhere that they want. So this is going to be the origin of the magnetic field of Jupiter, is this metallic hydrogen. Then if you go even deeper, you'll find that there is a planet in a solid planet in the middle of Jupiter. We don't know exactly what it's composed of because of the extreme pressures and temperatures. We can't duplicate those kinds of materials here on Earth, so we really don't know what the center of Jupiter is composed of. But all of the gas giants and the ice giants are going to have in their middle, they're going to have something about the size of the Earth, and it would be solid, and we just don't know what it would be composed of. Now, if you, down there at the bottom, you'll notice Earth in comparison to Jupiter. So remember that Jupiter is about 10 times the diameter of the Earth. And then off to the side there, you also see the inside of Jupiter and compared to the inside of Saturn, and you will notice that they're very similar, that they have a gaseous upper atmosphere, which then is compressed into a liquid hydrogen, which then is compressed into metallic hydrogen, and then they have a core. So the amounts are a little bit different inside Saturn than inside of Jupiter because the pressures and the temperatures are different inside those two planets. Okay, in our next segment, we're now going to talk about what is it that causes the weather on Jupiter and Saturn. So I'll see you in just a moment.